Okay, so we're going to take a look at how do we write the equation of a line in slope-intercept form if we know 2 points. One of those 2 points in this particular case happens to be the y-intercept, the point on the y-axis. We know 0, -1 is actually on the y-axis, so we know the y-intercept is going to end up being -1. We'll deal with examples where we're not given a y-intercept in tomorrow's lesson. But for today, we have 2 points. One of them is going to be the y-intercept. We know slope-intercept form looks like this. We need to go ahead and we need to find the slope, and we need to find the y-intercept. So we know the slope, we know the y-intercept. In the end, we know that we're going to end up coming back to the y-intercept is going to end up being -1. But we'll get to that in just a second. The first thing we're going to do is we're going to go ahead and calculate the slope. So I know that the slope is equal to change in y, or y2 minus y1, over change in x, which is x2 minus x1. So to find the slope here, let's go ahead and find our y-coordinates. I'll mark our y-coordinates in green. So they are -1 and -7. And then I'm going to also subtract my x-coordinates, which I will mark in, it's kind of boring, but I'm going to mark them in gray. So I want to make sure I subtract my x-coordinates in the same order that I subtracted my y-coordinates. Since I started with the -1 on my y's, I need to go ahead and start with the 0 on my x's. So I'll go 0 minus 5. Okay, so this gives me my slope is going to be, make that into a plus positive, -1 plus 7 is 6 over -5. So my slope is now -6/5. I can come back to my equation, y equals mx plus b, and I now know m. Y equals -6/5 x, and I also know b from above, which is -1, plus -1, or y equals -6/5 x minus 1. And that's how you write the equation in slope-intercept form if you know 2 points. Basically the same as the other problems that you've been working on. The only difference is, in this case, we have to go ahead and calculate the slope first, and we had to also recognize that the point 0, -1 was actually our y-intercept. Let's jump ahead and look at one more example. In this case, we're going to start off a little bit differently. We're going to start off with some function notation statements. So let's just pick some numbers here. Let's do f of 3 equals -4 and f of 0 equals 5. I just made those up. This is basically the same problem that we just got done doing. The only difference is we're given function notation this time instead of actual order pairs. But we know we can convert these function notation statements into order pairs. In the first example, our x-coordinate is 3 and our y-coordinate is -4. In the second example, our x is 0 and our y is 5. So now, this is just like the previous example we've done. We know 2 points as order pairs. One of those 2 points is a little bit special. This guy is special because he's on the y-axis, which means we know that our y-intercept is going to be 5. All we need to do now is go back and find the slope, and then we can write our equation. So let's go with the slope. We know that m is equal to y2 minus y1 over x2 minus x1. I'm going to subtract my y-coordinates. I'm going to do 5 minus -4 because that's going to give me a nice positive value. That's why I chose that order. It wouldn't really matter though. And then I'm going to do 0 minus 3, subtracting my x's in the same order. 9 over -3 is -3. So now I know my slope, I know my y-intercept, and I can go ahead and write my equation. The equation for this line. In this case, it's going to be y equals -3x plus 5. So the equation for a line with the properties that f of 3 equals negative 4 and f of 0 is equal to 5 is the line y equals negative 3x plus 5. If we just go one more step, if we come over here and take a real quick look at what this would look like on a coordinate plane, just kind of bring all the pieces together. So let's just turn this into a nice x and y axis. If I take the point that we just found, or the equation that we just found, which was y equals negative 3x plus 5, y equals negative 3x plus 5, and we have these two statements, f of 3 equals negative 4, and also we have f of 0 equals 5. Let's see how all these pieces come together in a coordinate plane. So what I'm going to do is I'm going to graph the line, the equation that we just came up with, y equals negative 3x plus 5. So I'm going to start by going up 5. I'm going to rise negative 3, so I'm going to go down 3 and over 1, because my slope is negative 3 over 1. I'm going to do that a couple times just so I can get a good look at my line. Let's do one more. Now I'm going to do my best to draw a nice straight line, but we all know how this is going to end up. Oh, that wasn't too bad. Now I want to see how that equation and these statements are related. Well, we know f of 3 equals negative 4 means that when x equals 3, y equals negative 4. So I'm going to switch over here to red to highlight this. So if I find the point 3, negative 4, 1, 2, 3, 1, 2, 3, 4, it takes me right to that point. So we can see that it is in fact true with the equation that we came up with, that f of 3 does equal negative 4. Or we can go one step further, and let's check the second point also. Let's see if this one is correct. F of 0 equals negative 5, sure it is, that's our y-intercept. So these two function notation statements ended up corresponding to points on our line. We could also find one more thing if we really wanted to just kind of beat this one to death. We could go back and plug our x's in for x and find out that we'll get our function values for y. For example, negative 3 times 0 plus 5 is 5, and if we chose the first point, negative 3 times 3 is negative 9 plus 5 is negative 4. So all the pieces are kind of coming together numerically, graphically, and then of course we had the analytic approach to finding the equation for the line. Good luck practicing, and we'll keep working on this over the next coming days.